Hello, Bronx Middle School Math. I hope everyone had a fabulous Thanksgiving weekend, but trimester 2 is starting. It is today. Today is the beginning. We are starting off trimester 2 with unit 3, and it's all about fractions. We are going to be adding fractions in lesson 1, but not just adding fractions. We're going to be manipulating these fractions. And I'm sure you're wondering are we taking advantage of are we lying to these fractions so that we can get what we want? No, not that kind of manipulating. No. We are changing the way we view it so that we can add it. Now, I'm sure you know, let's go to our goals first. So y'all learned about fractions and how to handle them in 4th grade. We are expanding your foundational skills and knowledge. We are adding to what you already know. If you have forgotten, I don't know, if somebody Control-Alt-Delete your brain and you forgot everything about fractions, do not worry. In the description of this YouTube video, I am adding all these videos right here. These are video recommendations for everything you would ever need to do with fractions. And so adding and subtracting fractions, that's what we're doing today. So if you don't like my voice or you don't like my videos, well, lucky for you, there are substitutes. Here we go. So that is going to be in the description below. Check those out. Please take the initiative and check them out. So we're going to be going over lesson 1, manipulating the fractions so that we can add them. So let's begin with the first one, 1/4 plus 1/4. Y'all know the rules for adding fractions. When we add a fraction, here, I'm going to draw, whoop, can I go back? Okay, I'm going to draw so that we cover these because I want you focusing on the first one. We will get to the other one soon enough. So when we add fractions, the denominators need to be the same. So 1/4 plus 1/4. The denominators need to be the same. And look, they are. 4 and 4, those are the same. We're in luck. So this problem is pretty easy. So the denominator is the same and we don't change it. Now all we add is the numerator. So 1 plus 1 equals 2. 2/4. We can simplify that. We want to make the denominator as small as possible when we're simplifying. So an easy, in fact, basic way to simplify a fraction is ask yourself, can I divide by 2? And you have to be able to divide the numerator and the denominator by 2. It can't be one or the other. It has to be both. And so lucky for us, both the numerator and denominator can be divided by 2. So 2/4 can be simplified into 1/2, 1/2. So let's see that. So let's say this is a candy bar and I only ate 1/4. That would be 1/4 because it's 1 out of 4 total pieces. So if I'm adding 1 out of 4 plus 1 out of 4, that is going to give me 2 out of 4. So that means that I have 2 out of 4 total pieces. Let's go to another example. Okay, 1/2 plus 1/4. This one is a bit tricky because the denominators are not the same. So we can't simply just add across like we did in number 1. We have to do some work here because we need to get the denominators on the same unit so that we can compare them evenly. Because right now, it's kind of like we're comparing pieces of cake. So they're not on the same unit, so we can't compare them fairly. So I want to make sure we can get these pieces to the same size so that we can compare them. So I want to get 2 into 4. That would be the easiest option because the denominators need to be the same. Well, what can I multiply 2 by to make it 4? 2 times 2 equals 4. Now, a lot of scholars in class were asking me, why did I multiply 2 over 2? Well, if we multiply the bottom, the denominator, by 2, we have to do the same thing to the numerator. The numerator gets jealous. If you do one thing to the bottom, you have to do it to the top as well to keep things proportional, to keep things even. Now, the reason why we're doing 2 over 2 is because 2 over 2, that equals 1. This is what we mean by manipulating. By doing 2 over 2, we are manipulating it so that the denominator will be the same as 4. So watch this. When I multiply fractions, I multiply across. So 1 times 2 equals 2. And then 2 times 2 equals 4. 2/4. Where have I seen that before? We found that in the last problem. Remember? 2/4. And that simplifies to 1/2. Wait. Miss Tharp, what was the point of that? If 2/4 equals 1/2, then what is the point of me even multiplying by 2 over 2 in the first place? Because we have to get the denominators the same. This allows us to compare it side by side. Which is bigger, 2 out of 4 or 1 out of 4? It's now that the denominators are the same, we can compare it. And we can add and subtract it. So multiplying by 2 to get the denominators the same, that's manipulating the fraction so that we can add or subtract it. So 2 over 4 plus 1 over 4 equals. So when we're adding fractions, the denominator needs to be the same, which it is. Boom. Now we just add across the numerator. 2 plus 1 equals 3. 3/4. But if you're more of a visual person, do not worry. Let's go down to our pictures. We need to get the denominators the same. 4 is the easiest option, which is why we multiplied 1/2 by 2 over 2. That is manipulating the fraction so that we can get it to the same denominator. So look, if here's 1/2. If I added 1/4 to this 1/2, I could just simply, and we can see that in the picture right over there. Okay, take Make sure you write these down or pause the video because I am erasing. Okay, so let's do the next problem. 1/8 plus 1/8. Y'all, too easy. Y'all know how to do that because that's just like the first one we did. The denominator is the same, so all we have to do is add the numerator across. And that is going to be 2 over 8. So 2 out of 8. Let's go down and look at the visual. Whoop, I went too far. There we go. 1 over 8 plus 1 over 8. The denominators are the same, so adding is easy. 2 over 8. Okay, let's shake things up a bit and go on to our next problem. 1 over 2 plus 1 over 8. 1 over 2 plus 1 over 8. When we are adding, the denominators need to be the same. So, what do I need to multiply 2 by to get it to 8? The easiest option would be 4. So I'm going to manipulate it and do 4 over 4, which we know is 1, because 4 divided by 4 equals 1. We're just doing that to manipulate it to get the denominators the same so that we can add and subtract. And we don't need to multiply 1/8 by 4 over 4 because 1 over 8 already has the correct denominator. So we're good. We're just focusing on 1/2 multiplied by 4 over 4. So when we multiply fractions, we multiply straight across. 1 times 4 equals 4. 2 times 4 equals 8. So now we have 4 over 8 plus 1 over 8 equals 5/8, or 5 out of 8. So let's say you had 8 pieces and you ate 5 out of 8. Let's go down and check that out. Here we go. So to get the denominators the same, we multiplied 1 over 2 by 4 over 4. That way we could get 2 on the 8 denominator, which gave us 4 over 8. So look, we have 8 pieces and we have 4 out of 8. Now that is clearly half. So we know that 4 over 8 can be reduced to 1/2, and this is how we see it. All right, now to our final one. 1/4 plus 1/8. 1/4 plus 1/8. Now the denominators are not the same. We need to get the denominators the same. So 8 would be the easiest option. Let's multiply and manipulate 1/4 to get it to 8. So what can I multiply 4 by to get it to 8? 2. So 2 over 2, which we know is 1. We are just manipulating the situation so that we can add or subtract. One-fourth multiplied by 2 over 2. When we multiply across. 1 times 2, 2. 4 times 2, 8. Plus 1 over 8 equals. So when we add, the denominator is the same, so it stays the same. And then we just add across. 2 plus 1 equals 3. 3 out of 8. So the reason why we manipulate is because, look, if I wouldn't have manipulated, let me show you what it would have been like. We would have had a piece, and excuse my terrible pie, but it would have been 4 pieces because, look, 1/4. So 1, 2, 3, 4, and 1/4 would have been just 1 piece. But look, and then I'm comparing it to a pie with 8 pieces. So the reason why we manipulate it is to make it the same number of pieces. That's why we're manipulating it. Because now that I manipulated it, I have 8 pieces down here. 1, 2, 3, 4, 5, 6, 7, 8. And that's the same portion. That's the same size as 1/4, but we just made more pieces. So it's kind of like if this was a pizza, would you rather have 2 small slices or would you rather have whoop, thought we were in shapes. There we go. Or would you rather have 1 big slice? Either way, it's the same amount of pizza. The way you're cutting it is different. When we manipulate and multiply 1/4 and multiply it by 2/2, we're just cutting more pieces. You can still eat the same amount of pizza. You're just going to cut it differently. That's what we're doing when we manipulate. All right. So we are going to go into our Scholar packet now. The Scholar packet can be found on the Scholar Work section of the Google Classroom. But we are going to focus on problem 2. So please go to your Scholar Work packet, problem 2. Ooh, and I'm seeing there were some problems there. So let's make sure we write down the correct, because it seems like when I downloaded it that the format messed up, which I apologize for. So here I went and checked and we have Mr. and Mrs. Reynolds went on a run. Wow, couple goals. Mrs. Reynolds ran for 6/10 of a mile and Mr. Reynolds ran for 2/5 of a mile. Who ran further? Use benchmark fractions to prove your answers. So we are comparing 6/10 with 2/5. Which one is bigger? Who ran further? That's what we are doing in this problem. So what we need to do is to get both of these fractions, it's like the pizza I was just talking about. We need to make sure that each pizza has the same amount of slices so that we can compare the size of each slice. But let's get back to running. So we can say that Mr. and Mrs. Reynolds are running off their pizza, okay? That's why they went on a run, because they ate too many pizzas from the problem before. So we need to get 6/10 and 2/5 on the same denominator. what would be easiest? It would be easiest to get 2/5 on the 10th denominator. So let's manipulate 2/5 so that we can compare it with 6/10. So 2/5, what number can we multiply 5 by to make it 10? I know you're probably annoyed at how easy it is. 2. So let's manipulate that to see what we get. So 2 times 2 equals 4. And then we're going to do 5 times 2 equals 10. 4/10. So now we are comparing. Which is bigger, 6/10 or 4/10? If you had a candy bar and there are 10 pieces, would you rather have 6 out of 10 or 4 out of 10? 6 out of 10 is more. And 6 out of 10, that is Miss Reynolds. So the missus ran 6 out of 10, and Mr. ran 2/5. There we go. So the missus ran more. So let's use the benchmark fractions. So it's kind of like a timeline. Not a timeline, I'm sorry, a number line. Do you remember the number lines from trimester 1? So here's what we do. So 10 out of 10, that would be 1. And then halfway, that could be 5 out of 10. And over here, at the beginning, that's going to be 0 out of 10. I'm going to put this at the top so that everything is even. I am paranoid like that. There we go. So everything is the same. Okay. So where would be 6 out of 10? Let's place the misses first. 6 out of 10. Well, just like a number line did before, we need to do 1, 2, 3, 4. Here's 5, 6, 7, 8, 9, and there's 10. So let's label these. 1 out of 10, 2 out of 10, 3 out of 10, 4 out of 10. Then we have 5/10, 6/10, 7/10, 8/10, 9/10. All right. So Mrs. Reynolds was 6/10, and that is right here. Mr. Reynolds was 4/10. That is right here. So we can see that Mrs. Reynolds ran the furthest. All right. Aliyah made brownies for her book club. Ooh, I wonder what book they are reading. After book club, she was left with the trays below. What fraction of the tray does Aliyah have left? So we can see that 1, 2, 3, 4. So these parts were eaten, and she's left with this much. She's left with 1 out of 4. So that's 1/4. And then let's go over here. I'm going to label this tray 1. And we'll do that tray B, or tray A, and then tray B. Tray B has 1, 2, 3, 4, 5. It was cut into 5 sections. And we can see that all these were eaten, but she was left with 1. So 1 out of 5. What fraction of a tray does Elia have left? So they want to know these combined, how much of a single tray is left? So what we need to do is to get these fractions on the same denominator. Goodness. Okay, well, it was easy before because before we were doing like 1/2 plus 1/4. So I could turn 2 into 4. But I can't turn 4 into 5. Okay, so let's start just going through the multiplication chart. So, okay, I can't turn 4 into 5. Okay, well, 5 times 2 equals 10. 5 times 3 equals 15. 5 times 4 equals 20. So now let's check, does 4 go into any of these? Does 4 evenly go into 10? No. Does 4 evenly go into 15? No. Does 4 go evenly into 20? It does. It goes into 25 times. Well, let's check the 4 multiplication chart. 4 times 2 equals 8. 4 times 3 equals 12. 4 times 4 equals 16. 4 times 5 equals 20. Does 5 go into 8 evenly? No. 12? No. 16? No. 20? Yes. We need it to be even. It cannot be left over with a remainder. So both numbers that they have in common and that they can go into evenly is 20. 4 can go into 20 evenly, and 5 can go into 20 evenly. So let's manipulate these fractions to get the denominator 20. That is the common denominator. I am manipulating these fractions so they can have a common denominator. So let's begin with 1/4. What do I manipulate 1/4 by to get it to its common denominator? Remember, the common denominator is 20. So what do I multiply 4 by to get 20? It is going to be 5. So when I multiply across, 1 times 5 equals 5. 4 times 5 equals 20. Beautiful. I've manipulated it so I can have the common denominator. All right, now let's do 1/5. The common denominator is 20. What do I multiply 5 by to get 20? 1 times 4 equals 4. 5 times 4 equals 20. So I have manipulated tray A and tray B to get them on a common denominator. Now I am going to add these two fractions together to see how many brownies, how many total brownies are left. So let's add 5 over 20 plus 4 over 20, and I am getting 9 out of 20. But I'm asking myself, can this be simplified? So remember the basic way that I told you to check if something can be simplified. Divide it by 2. Can I divide 9 by 2 and get an even, solid, whole number? So it cannot be simplified anymore. 9 out of 20, 9/20ths. So that means that there was a tray of brownies. And let's say that it was cut into 20 pieces. I am terrible at cutting pieces. Is that 20? Boom, beautiful. And there are, so here are 20 pieces, and there are 9 left over. So let's color in 9. So it can be colored in like that. Or it can be colored in as 2, 4, 6, 8, 9. Either way, when you combine these two trays, it is going to look like that, 9/20ths. Scholars, please remember, if you need any help on basic fraction stuff that we learned in 4th grade, please go to the description and you will find these videos linked in the description. You will also find it on the Google Classroom for Math. All right, scholars, that is it for me. Please make sure that you have submitted your exit ticket and your homework. Make sure you submit those 2 things. Watch these videos and have a great day.